Applying wind load to the structure. What is loading? Load is the external force applied on the structure which causes changes in the structure. Loading type. The IS code used for loads. Dead load part 1, live load part 2, wind load part 3. Formula for calculating dead load in STAAD Pro while applying wind load. Wall load, dead load of slab, floor finish load. These are the formulas of calculating dead load. Live load. The reference from IS 875 part 2. Next, moving forward for wind load formula, where Vz equals to Vb into K1 into K2 into K3, where Vz design wind speed at any height z in meter per second, K1 is probability factor, K2 is our terrain height and structure size factor, K3 our topography factor, and Vb our basic wind speed. This is the formula of calculating the value for Vz, and Vz equals to 0.2 Vz square. This we choose our basic wind speed category. For Nagpur it is 44. Then next, moving forward, risk coefficient factor depends upon the span of a structure. If it is permanent, we can choose it as 50. It is temporary for 5 years. For 44, we have to choose the values. Next is our terrain category. Terrain category A, B, C is chosen by keeping in mind of our building structures surrounding. Category 1, exposed open terrain with few or no obstruction. Category 2, open terrain with well few. Category 3, terrain with numerous closely side. This all categories can be seen in IS code. Now moving forward for topographic factor. That is Pz equals to 0.6 Vz square. Yeah, let me correct it. So moving forward with the models, I am taking AutoCAD plan as a reference. This plan can be modeled in STAAD Pro, and we will have our geometry in STAAD Pro keeping this as a reference. We will choose grid, linear grid option. That is default grid, linear. Now I will make this is in top view. I am making it in top view. This is snap node beam method. It is in STAAD Pro, one of the easiest method to create any geometry in STAAD Pro. It is very simple and easy to create a geometry in STAAD Pro. The dots you are seeing, that are called nodes. Nodes are the joints, which is very important in STAAD Pro. Through node only we have to connect one beam with two nodes. So for making any beam and column, we have to take the help of a node. That's why this method is known as snap node beam method. Now I have created one part. After completing it, as you have seen, my plan is it symmetrical. So I will make a mirror of it, and by making only one part, I can create the whole plan. So as we are in top view, I have to mirror in upside. So I am taking X and Y as a reference. So this is our geometry is created. Now I'll select the complete. I will choose the reference node. And I will select the complete geometry, and as I have to mirror it at exact direction, so I will mirror it. I will add the additional beams. Now after that, we have to give properties to our geometry. As it is a thread like structure, so the next step is giving material or properties. So I had given the cross section of 0.230 meter rectangle concrete section. So the whole complete structure has been assigned with a property. So it is a hollow. So now I have to give the plate also. So now next step, I have given the plate. We can be given StatPro for providing floor or slab. So after creating a geometry, we have to create cross section. We have to assign that to our geometry. Then we have to assign a plate also. Then after that, we have to give some thickness also. Yeah, as our slab and our floor has some thickness. So by moving forward, in properties only, there is an option of plate to give a plate thickness. We have the separate cursor of selecting a plate. So now, as my one floor is created, by translation repeat, I will do the multiple copies of my floors. As number of step is 11, default spacing is 3. The gap between each floor is 3, and my multiple story is ground plus 11 more floors. Now the plate is missing, so I will select the plate. Yeah, this is how our 3D model looks. The plate is missing, so I will go in the plate cursor and select the only plate, and I will do the translation repeat. Same, we have to repeat it. 11 and 3, default spacing will be 3. Okay, then go to 3D rendering view. Then our geometric properties has been completely assigned. So first we had created our geometry. Next we had provided the properties. Now I have deleted the ground floor just to provide supports, because next is our supports. So there are number of supports, but we are providing a fixed support. I will select it. I will select all the nodes and I will assign to the selected nodes. Now my complete suppose had been assigned. You can see in the screen. Yes, yeah, that is the supports. Now moving forward, main part, load cases. First I will provide dead load. Dead load. Add. Then next is live load. Live load. Then add. Close. Now we have to provide the intensity. Intensity means how much dead load we are providing. So in dead load we only take self weight. So I will go to self weight. Next for live load, we take the member load. So here we have to provide the intensity. It is uniform. For global y-axis, global axis means a complete axis of a structure, and local axis means every member has its own axis. Then for plate, we have to provide the pressure intensity. Yeah, so this is how it's look like. Then assign. Yeah, now it's complete. Now next, moving forward for wind load, the most important, custom. Here we have to calculate as per ASCE 7. We have to click on that. Site location Nagpur, cheapest story structure, 10-story structure. So here we have to provide the information, category, in which category our building comes, basic wind speed 44 for Nagpur, exposure, B, building type of structure we are taking as building structure, apply. Okay, so automatically it updates the values. Then exposure factor, normally we take 1, add, close. So we had provided the wind intensity and exposure. Exposure you have to assign it to the whole building. Next, load cases. After providing the wind load by definition, here you have to separately mention wind load for different directions. We generally provide for positive x wind load, positive x wind load, negative x wind load for positive z, and wind load for negative z. So generally we provide for 4 direction. So we had provided. Now we have to add the range. Yeah, load positive x, then moving forward wind load factor 1, we always take it as a 1, and for negative x we take it as a -1. Positive z we take as a 1, and for negative z we take as a -1. So this thing we have to keep in mind while adding the wind loads. It's very simple guys, you can easily do it once you get familiar with the software. So you can check it whether it is assigned properly or not. So this is how we apply our wind load in our complete building structure. The next process we move forward for analysis part, whether to check any errors if we had in our software, what we had done in the complete till now, what we had done. So for cross checking it, we have to go to the analysis. So there is no errors, so we will go for OK. Then we can able to see the reports, the deflection, and for what load we have to analysis the buildings. So we can able to check the complete result in it. So this is how we can design a multi-story building in StatPro software by applying wind load. Just we have to keep basic things in mind. We have to take our IS code as reference, and next we have to be careful with our errors. So here we had increased the exposure factor, we had changed it. There is zero error, zero warning. Yeah, so okay. Apply. So that's it. The all calculation has been done. Complete analysis of a building has been done with no errors. This is how our structure looks. Thank you guys. At last, I am Wasim Sheikh, a civil engineer and CAD professional from CAD Center, Wardha Road, Nagpur. Thanks for watching this video, and it's really helpful for applying wind load. Hope you guys enjoyed it. Thank you.